Welcome back everyone, Lee here, and in today's video we're going to discuss Wireshark display filters. If you've ever been overwhelmed by the sheer amount of data in a Wireshark capture, then display filters are going to be your best friend for efficiently analysing and focusing on the specific network traffic you're actually interested in. Now before we jump in, don't forget to hit that subscribe button and ring the notification bell to stay updated with our latest content. Now let's get started. Let's start with some basic display filters that you'll find incredibly useful. The simplest filter is filtering by IP address. For example, if you want to see traffic to or from a specific IP, use ip.adder equals and then the respective IP. So in this case I want to filter it down to the quad 8's Google. And it's showing me that it's showing me all the traffic flows where not only the source was 8888, but the destination might have been 888 as well. Now say I only wanted to see the source packets that were 8888, then we would simply change this to ip.source, and that would show me all packets only with 888, no destinations. And if we wanted to just see the destinations, we would say ip.dst instead, and that would show you the destinations, of course. Wireshark supports protocol specific filters as well. Maybe we only want to see DNS traffic, so we would just type DNS. Or maybe we just want to see HTTP traffic. Or maybe we want to see both HTTP and DNS traffic. So in that case, we would use a OR operator. So HTTP or DNS. You can also create port-based filters, and these are useful for when looking for packets containing specific services. You might want to look for TLS traffic, so you could search for TCP packets with port 443. So I'd put TCP.port equals operator 443, and as you can see, this is showing ports both sourced and destined to 443. I can do the same for UDP as well. You could add the DST keyword in order to filter the destination port only. I might want to look for only ports over a certain range, so I could type in all TCP.destination port greater than 1024. And as we scroll down, you can clearly see none of these destination ports in this column are lower than 1024. One of the most useful commands is the membership operator. Now previously I used to say I wanted a range of ports. I wanted to look for 4 ports. I would say TCP.port.destination port equals 80. Then I would have to say or TCP.destination port equals 443, or, and as you can see, it's just long-winded. It's not a very efficient way to do it. So the better way to do this is to say TCP.destination port. You might want obviously the source port or just the port, and then we would use the membership operator, which is in, and then whatever you put in the curly braces will be the values that are being filtered on, in this case the ports. Must remember to use a curly brace. And one other thing to note is whenever it's green, you know you've done it right. Whenever it's red, the syntax is incorrect. And as we scroll down, we can see that it's only showing destination ports within the range of the bracket. We can also combine filtering, bringing together what we've learned so far. For example, I would say ip.source with an equals operator. Pick an IP that we've already seen. And I can use the AND operator. By the way, you can also do this one as well. Either's going to work, right? So say I do 2 ampersands, and I would say tcp.port equals 8009. And I would just simply get even more specific, and you're going to use this a lot. So as you become more comfortable with Wireshark, you can delve into more advanced filters. One of the ones which I find really useful is tcp.analysis.flags. And this is ideal when trying to troubleshoot slow application performance. It will show things like retransmissions, duplicate acknowledgements, out of order segments, etc. Another good filter to eliminate unnecessary background noise, basically packets you have no interest in, is to put an exclamation mark and then bracket the protocols you don't want to see. So in this case I would go, maybe I don't want to see ARP traffic or ICMP traffic or DNS traffic. And it would exclude those protocols, making it much easier to narrow down an investigation. You can also match a particular string with the frame contains keywords, and then put in the string within that you want to match within the brackets. So in this case, I went to the Top Gear website, and you can see it found it within the PCAP. I will say though, this is case sensitive, so in this, because it was lowercase this time, it isn't finding any packets once I'm uppercase. But you can use the matches keyword, and that is not case sensitive. You might be troubleshooting a web application and say you want to see all the HTTP GET and POST requests. I could type in http.request, and that would do that for us. I might be troubleshooting an application issue. Maybe I want to see how many TCP resets are occurring. Maybe I've got some sort of intermittent issue. We suspect it to be a firewall in the middle. That would also show you all of the TCP resets. We might want to see how many DNS requests couldn't be correctly resolved. In that case, we could type dns.flags.rcode exclamation equals, in other words, not equal to 0. And this would give us any DNS requests which failed. In this case, we had one here. There's no such name for WPAD. So obviously I cannot cover every display filter, as there's literally hundreds of them. But the best way to start learning them is by simply dragging items already within the capture into the filter bar and seeing what it ends up putting. To be honest, this is the best way to learn, and it's also a really fast way to apply filters when you're using Wireshark. Let me show you what I mean. So if we just clear off the bar, get back to the capture with no filters. Right, so say we want to filter on the source port, we could click on the port and just drag it straight into the bar, and you can see it did exactly what I taught you earlier on. Say we also want anything destined to this IP address, so we would drag that. And when you do that, you can see that it's asking for kind of what operator do you want it to use. Do you want it to replace what's already in the filter bar, or do you want to do a logical AND, or a logical or AND not? So in this case, with a port, you're probably going to do a logical AND, right? Because both conditions can match. So then it's going to put the double ampersand again. Like I said earlier, you can use that or the AND, they're the same thing. But just by doing this, you can learn. You can reinforce what you already know. So like, say if I clear this, I could say I want particular protocols. I could say, I want to look at all the HTTP 3 traffic, and I want to look at anything that matches 77 bytes in length. And from this, you could straight away say, right, well, I know what the greater than operator is. So maybe if I just say, okay, so I want to see anything bigger than, I don't know, 500 bytes. By doing that, you've now learned a new filter. And so this is what I suggest you do. I suggest you just practice with just dragging and dropping and applying filters. You can also apply them straight from within the actual packet. So say I want to look at, let's just get something that's TCP. Within the TCP header, you can look at the flags section. Say I just want to look at the SYN. I want to look at all the SYN packets. So you just drag it up, select it to replace it, and I could just say, okay, so TCP flags.syn. I want to see the SYN, so I want the flag to be true. And there you go, it's showing all the SYNs and the SYNACs. So just by doing that, I would recommend, just by doing that, you're going to learn, and I would recommend to play with it. Thanks for watching, guys. I hope this was informative, and I'll see you in the next one.